Okay, we're back, and it's COMP1050 Animation 2D Tools, Week 7, Part 2, and we're right into our air raid game. So we're going to talk about a simple game framework. This is a little bit of more of a longer one we're going to talk about here. It's about 43 slides, so just bear with me as we move through it. Okay, so very early type of arcade game, air raid, right? Actually, if you look at some of the earliest versions of air raid, Seawolf, which is kind of a interesting version of the same kind of thing, in the actual arcade you had this, and this is a fake periscope, but actually what you had is an actual periscope, a physical periscope that you could touch in the arcade. I don't know if you've ever seen this kind of thing in today's arcade, but back in the day, I can say that now, back in the day you actually had a periscope to make you feel like a submarine commander that you'd look through, right? Yeah, and you do the same kind of thing. You have these planes that go through, or boats, and you press the button on the periscope, or on the controls are actually on your periscope itself, or on the actual arcade game, and you'd fire a bullet, and it would hit the plane or whatever, and that's how you get your points, right? And you can actually change the angle of your periscope to see different parts of the screen. Okay, so more of a physical game. It was more of a, I like to call it a figura, like almost like a little gimmick, right, to kind of get you to play the game, right? Anyway, and there's a bunch of other competing games like that, like one called Periscope, actually. There's one called Sea Raider and Sea Devil, and they were all electronic games that you could play. But basically what it is you got this anti-aircraft gun, right, like the gun that I showed you previously, and all it does is moves left and right on the bottom of the screen. That's all I can do. You can't go up and down. All I can do is left and right. And then all you have is you have a limited number of bullets, and you can strafe the planes that come by with this limited amount of ammo. Okay, so again, we have these three different objects, right? We have airplanes, we have the turret, so the actual gun, the anti-aircraft gun, and bullets, right? That's what we have. We have these three things, right? So let's take a look. There's actually a few different pieces to the code now, right? So if I look at the actual file itself, I'm going to open up air raid here in Flash. So here's air raid 1. And if I look at my library in Flash, I have a bunch of different symbols, right? So I have this bullet symbol. Here's my bullet. I'm just going to go to 800% here so you can see. It's just this, actually the bullet itself is 3 different bullets. That's what it is that are going to fire up. So it's almost like an array of bullets that fire up, right? Our airplane, if you notice, this is one of the airplanes. On frame 1, right, of the airplane looks like this. But as I go from frame to frame, the different planes, they kind of change the way the planes are. So they've got a different selection of planes. And then starting from frame 6, we got a bit of an explosion going on. So there's one part of the explosion, and if you notice, it kind of lasts for a couple frames. Nothing really changes, and then it goes away. All right, so the explosion, hasn't really changed. I mean, they could have made this a little better. They could have made the explosion kind of sizzle or something. And by the way, all these games I'm going to be showing you today, none of them have sound, so that's something definitely that's easy to add in. We talked about that last week. But that's all this airplane does. The anti-aircraft gun is just a gun, right? Here it is. It's a platform, and it doesn't do anything. It just moves left and right. There's only one frame to it at all. So it's one little symbol, one graphic here. Actually, they're all pretty nice graphics. If you notice, one of the nice things I like about all the ones that are in this game is they've got this heavy border on it. It kind of makes this black border kind of looks good, and they got a little bit of you got some. It's a simple object, but you've got kind of this faux 3D effect with different gradients that they're using to create the symbol. So a bunch of maybe different components that are put together to make this look the way it is. And if I actually click on it, and if you can see, all it is, if you notice, each component is modifiable, right? It's almost like they put a bunch of little objects together to create this symbol. So it's not just like a graphic that's been stolen and put together here. It's actually been made here in Flash, or been made Flash compatible. It's been converted. Okay, so we've got a few symbols here. We also have this basic button. Here's our basic button, Our basic button is a button like this, and we have only one state to it. I don't have an over, down, or a hit state, right? So I only have one state to the button, as you can see, and there is no text here whatsoever, right? So the button, I mean, we've called it a button symbol, but there really isn't anything there. Now, one thing to notice about everything in our library here when we look at this movie, right, is each symbol, other than the font in our library. So here's another, we have a font here as well. But each of the symbols in our library has an associated class that goes with it. Okay, so we have a bullet class, a basic button class, an airplane class, and an anti-aircraft gun. Let's take a look at those classes. So if I look at each of those classes, so here's my bullet class. So if I right-click and go Properties, I can see that there's a bullet class associated with it. If I click on the pencil, edit the class, and I bring it in here, this is my bullet class. So I actually have a definition for my bullet. When my bullet is instantiated, it has certain properties, right? Going back, I can do the same thing for my airplane class. So I'll go back, here's my properties, and I'll edit my airplane class here in Flash. There's my airplane class. And if I go back again, here's my anti-aircraft gun, right? So properties, and then anti-aircraft gun here in Flash. There's three different object classes that we've created. So we have document classes, the document class for the main game, and then we have a bunch of object classes for each of the symbols in our game so far, right? One more. Let's see if there's one for the basic button. Let's see if there's that, or if it's just an association for us to put it on the screen. So here, I can tell you right now that the base class for this basic button is, if you notice, Flash Display Simple Button, which means if I click this, there's not going to be anything there but a stub, right? There, this is the stub that we're talking about here. And there really isn't a class definition. We haven't really done anything with our simple button. It's just a simple button. It's extending the simple button class for Flash, and we're inheriting here for our button class called basic button. But it really doesn't do anything. So we're not going to save that one. Okay, so a bunch of different items that we have going on. So there's our basic button right there. We have our basic button, and if you click onto it, we also have a couple things in our timeline here for our first frame, right? One thing that they didn't put on here, which is, and again, I'm just going to say how it is, right? Our background isn't a symbol. It's actually hard-coded, if you will, into the background of our movie clip, right? So here's our movie clip, our main timeline. And if you notice, if I click parts of the background, like the snow cap, right? This whole thing here is just one big, it's different symbols or different graphic objects that have been layered here in our background. That's all it is, right? And it doesn't matter where we go, there's one keyframe that kind of goes across from one to the next, and the background doesn't change at all. So the background stays fixed. And then as such, we don't have to really instantiate the background. We have an object that's in the background, which is just a bunch of graphics, and they just sit there, okay? So the graph, we don't really interact with that too much. We do, however, have some labels. So we have a label here, right? So here's a score label, right? And if I go to properties, the score label actually, even though it doesn't have a class associated with it, like it's not an object, it is a classic text label that has an instance name called show score, right? If you notice here on the top right corner in our properties, show score is the instance name of this label. We also have show shots. So that's an instance name. So I can actually target, I can target that area for show shots and show score, and I can actually change the values of those things. I can actually concatenate or add a string to both those things so I can show my score and my shots left. Okay, that's how we do it here. When I move to the third frame, if you notice, the score, the show score, and the shots left labels remain. I also have this game over text, if you will. And again, if I was to hide everything, so here's our labels. If I hide the labels, you notice now the game over text is hidden as well, right? That's part of our label layer, if you will, right? This doesn't really have any, it's not been instantiated, it's not an object, it's just a bunch of text for game over. So this is something that's not generated, it's just there and it stays there for our game over frame, right? So that's one thing to notice as well. Again, our text carries over. It goes from it's our score. It's in the corners of our. It's a status update for our score, and our background again is our background layer for everything else. Okay, just the way the game is kind of laid out. So we do have a couple of classes. We also have one other class we haven't looked at, right? And if I was to look at it, let me just look at this for a second. I'm going to go to my first frame. Right, so here's my first frame of the animation. I have this AirRay document class as well that I'm going to look at. So that's our kind of our main class or our document class for the AirRay game. So this is our AirRay game, right? And then we have our AirRay class, and inside there we also defined our object classes. So you and I are building a game together, and I say, well, here's all the components you need. You need a ship, you need aliens, you need an explosion, you need this, you need that. Each of these things are going to have these objects are probably going to be in their old folder, if you will. When we create our game, our package is going to be, you know, the package for the classes that are objects are going to be in an objects folder, as an example. That makes sense, right? Because you're going to have an alien, you're going to have a hero, you're going to have a different kind of different objects that are in the game, right? And each of those objects for us, they're going to be part of our library, so to speak. But maybe, and then this is for Starling, you don't really need to have an actual library of things to instantiate. You're going to bring everything in, you know, with ActionScript. Okay. So again, we have these different object classes that we're going to have, like we talked about. Let's talk about these airplanes, right? So again, airplanes are actually very similar to that animated object we looked at in our last movie that we took, our last video we had, right, our tutorial, right? So in part 1. And again, it accepts some parameters for the inside of our when we instantiate our plane. We want to do a couple things, right? It uses the time to track the difference between frames. That's one thing. So when our plane moves across the screen, it uses time-based animation, like we talked about. And it uses this enter frame event to step forward the animation itself. So the enter frame, every frame that goes by, and again, I think we're operating here at 12 frames per second. Let me just take a look within our flash. Oh no, it's actually 60 frames per second. We're at 60 frames per second, right? And again, when we're at 60 frames per second, can we sustain that? Probably in the real world, and unless you're using GPU acceleration, probably not. You won't get that many frames per second. Your stats will show. If you can show the stats for your game, it's not going to be that high, right? But anyways, 60 times per second, we're gonna do this. We're listening for these frames to move. So 60 frames are going to move in a second. So we're going to have quite smooth, potentially quite smooth animation going on. All right, let's take a look at this. So in the airplane, which is like our animated object, when we declare the class, it's definitely going to extend the movie clip superclass. So it's still a movie clip. When we move to the Starling framework, we're going to rarely use movie clips because movie clips have a higher overhead than sprites. Sprites and movie clips are almost identical. The only difference is that in movie clips, you can have embedded animation. In sprites, you cannot, right? So, and again, it works well if you're using a library and Flash CS6 as a development environment. If you've already kind of created symbols, then it's okay for you to make them movie clips. You can't really make them sprites. You have 3 options. You can make it a graphic object, a button, or a symbol, right? A movie clip, right? And to me, movie clip is probably the best all-round class you can use for your symbols in Flash. But when you do ActionScript-based games, you may not be using movie clip because it's higher overhead. You may choose to use Sprite as a container. Okay. So again, we have a couple of instance variables here in the class for airplane. We have our dx, so our speed and direction. That's what this dx is, right? So x movement, because remember the planes, they don't move up and down. All they do is they move in in the exact same path, but sometimes they'll move to the left, and other times they'll move to the right. Okay? We'll also keep track of our animation time here with our last time variable. Okay, the constructor function takes 3 parameters: side, speed, and altitude, right? So side is which side the plane is going to materialize on. Is it going to be on the left side of the screen or the right side of the screen? Your speed is going to be the speed of the plane, and your altitude is how high it's going to be within a band of height, right? So the speed parameter, that's the first we're going to talk about. You could have a negative sign in there. So negative speed obviously would be your plane is going in the other direction, right? So a left to right plane, right, with a speed of 80 pixels, has a delta x or speed change of 80. But a right to left plane, so a plane coming from the right and moving to the left, because we count everything from the top left corner of our screen, it's going to be a negative 80 pixels for speed, right? And then really the vertical position, which is the altitude, is anywhere between the top 50 pixels of the screen, right? That's what's going to happen. So between 0 and 50, the top of the screen, and as low as 50 pixels down from the screen. That's where the planes are going to come in. That's really the altitude. They're going to stay fixed at that altitude, though. They're not going to warble. They're not going to kind of go up and down. The planes are going to stay this fixed, right? In this particular game, we're also going to do this. We're going to use the scale x property to flip the plane. Remember what scale x does? It changes the scale of your x dimension, if you will, the width. So if I change the scale of the width to half, 0.5, the plane will get skinnier and look really, really ugly. But if I go -1, it actually flips the image of the plane. This is a really cool trick you can do with your game. You flip the image of the plane so it looks like it's the other way. It's an inverted image of the plane itself or the object. Okay, so that's really our kind of our high level. We also use our go to and stop animation, our timeline navigation, because the plane itself, each plane symbol or movie clip itself has, remember, all those different frames. Between frame 1 and frame 5 is 5 different kinds of planes. And then between frame 6 and I believe frame 8, you have this explosion that happens, right? That's what those, it's embedded in the plane's timeline. So we're going to use the go to and stop timeline navigation function to move what plane we're looking at on its own timeline. What I mean by that is if I go back to Flash, right, and again I'm going back to the airplane. So here I'm looking at the library, and I go to airplane. And here in the airplane, if I want to look at preview instead of frames, so here's our preview, I can see that each of the frames has a different image of a plane down here. I'm just going to make this a little larger for everybody here. So I'll make it 400. So here's our frame 1 is this green plane. Frame 2 is this blue plane with a little bit of jets, right? Frame 3 is this yellow plane with it's like a biplane, right? Frame 4 is another kind of propeller plane, this old type of propeller plane with red. And there's another kind of yellow and green plane that looks more like a jet in frame 5, right? So frame 1 to frame 5, I'm going to use this go to and stop navigation, timeline navigation in the plane itself to give me a new image, just like we did in the cards. When we flipped the cards last week, we flipped the cards. We had a bunch of different card images. Here we're using different plane images, and we're using go to and stop because if I say go to and play, the plane is going to flicker. First of all, it's going to be one image, and then it's going to be the other image, and it's going to keep on cycling. We don't want that to happen. Okay, let's just go back to normal size. This is the normal size frames, and I'm going to go back to the PowerPoint for a second. So that's one thing that we're going to do. We're going to use this go to and stop method. Okay, so let's take a look at this. If we're going to check the side, which we're going to get into the constructor right here. Here's the constructor for the side, and the side is going to be left or right. So it's going to accept a string variable that we're going to set. So we're going to say it's left side. That's where it's coming in, or right side, right? And then the number is going to be speed is going to be a number of pixels that it's going to move, right? And altitude is going to be how high it's going to go. So let's take a look at this. If my plane is coming in from the left side, well, you know what? This x, so my x coordinate is going to be -50. Where's -50? Where's minus 50? Off screen, right? So my plane is physically starting off the screen, minus 50. Why would I do that? Why would I not start the plane on the screen? It will just appear. So it look like really shoddy graphics, right? If this plane just goes poof and appears in midair, it's going to come onto the screen. So 50, you know, if it's off the screen at 50, it's going to come into the screen. It's going to appear coming in from the side of the screen. It's going to fly from the left at a specific speed that we're going to get as a dx value of speed, our speed that's set inside of our code, right? We're going to set the scale to -1, right? Because we're going to reverse the picture. Because remember, our plane looks like it's right to left. See? Our plane looks like it's going from right to left. But we want it to go from left to right. So we have to reverse the image of the plane. We're going to flip the plane. So it looks like it's going this way, from left to right. Okay, here, if it's coming from the right, well, we want to start it off screen again at 600. So that's, again, 50 pixels off to the right, right? And we're going to have a negative speed because when we come from the right and we go to the left, our speed is going to be reversed. Because remember, our coordinate system starts 0, 0 on the top left corner of the screen, and we want it to go to the left. We're actually flying at a negative speed. And we're going to flip our scale back to 1. So our scale is going to be back to, so the plane looks normal again. Okay. We're also going to change the altitude, right? Because we're accepting this altitude parameter right here. And this y coordinate, when we say this, why do we say this? It means this object, which is the plane itself. The plane itself, the y coordinate of the plane, is going to be whatever the altitude position is going to be. And then we're going to say this, which means this movie clip, right? This version of the plane, go to and stop at a random location, a random frame between 0, 1, because 0 plus 1 is 1, 1 to 5. So it's going to go between frame 1 and frame 5. Go to and stop at that frame so that way my image, my graphic, will look different according to which random plane I'm going to get. Then I'm going to get this I'm going to do this add event listener, and I'm going to move my plane, just like we did with my animated object. It's exactly the same pretty much, right? And here's my move plane function, or method, if you will, right? We look at the time passed. This is the animation. This is where the animation comes into play, right? We're going to move the frame according to the delta x, the change in the frames in the plane speed for and we're going to take the time passed, and we're going to poll every frame as an example. We're going to poll, and we're going to take the total time passed, the difference between when we're getting the current time and the last time we polled our last frame that we polled our timer, and we're going to divide it by 1,000, and we're going to get the change in milliseconds. We're going to take that amount of time, right, and we're going to animate based on that. We're going to say our delta x value is equal to whatever the value of our movement is. So for example, if our movement is 70, let's say 70 pixels per frame, we're going to take that and multiply it by a fraction of the milliseconds that we're going to get, depending on how many frames we've already passed, right? Okay, so let's see if it's off the screen. If my delta x is less than y, less than 0, and our x, so our speed is nothing. So if our speed is nothing, and our x coordinate is less than -50, so back to that starting position off screen, then what I want to do is I want to call this DeletePlane function. Okay, we're going to go get there in a second, right? Or if it's greater than 0, so we're traveling at a really cool speed, so positive direction, going to the right. This is if it's going to the right, and where our plane is greater than 600, so off the screen at 600, then delete the plane. So both times, the delta x being positive or negative just tells you the direction we're going in. We could have also checked, instead of passing in a delta x and delta y, theoretically we could have passed in left and right here as well. So if it's left and it's greater than minus, so we're off screen, then remove the plane. Why are we removing the plane? Come on, people. I know there's only a few of you here, but because everyone else took off after the exam. But why do we move the plane? Why do we remove it? Why bother? The plane would stay in memory. You know what? Justin has it good. The plane would stay in memory forever. What's wrong with keep on like adding planes and objects to memory? Who cares, right? We have tons of memory. We have gigs and gigs of memory, right? Well, yeah, we do here on the computer, but on a device, if we are playing a device, we only have a limited amount of memory. And really, the proper methodology is, as you as a programmer should remove and do your own garbage collection when it comes to games. Garbage collection does not happen automatically unless we do it. When we're programming games, it's a very high-level application, right? Much more challenging than producing a UI, right? Like the one we did this morning in our little easy exam, right? Here, we're actually physically positioning an object in memory, and we got to clean it up. So that's why we're going to do this DeletePlane method. And here it is. So our DeletePlane method here is we're going to do two things. We're going to say we're going to go to the parent movie clip. Remember, our plane is a movie clip, but the movie clip itself is within another movie clip. It's in our main timeline, which is a movie clip of its own, right? So if I say parent RemovePlane, right? We're going to go into the RemovePlane function in a second, and we pass in this. We're passing in a reference to this particular object. So we're saying, hey, remove this plane from my parent object, which is the stage in this particular case, right? In order for to do it properly, so we know what parent is, and because it's a movie clip we're removing, we have to cast. That's where when we start putting movie clip and in brackets parent, we're casting our parent object as a movie clip. If you don't do this, you'll get an error, right? So you need to do that. And then we're saying parent remove child this. So not only are we removing the plane, so we're physically removing, we're going to have a function that does something with the plane in a second, right? But we're actually physically removing the child from the parent. We're taking it away, we're eliminating it from the stage. And then to clean up further, we're going to remove the event listener for the plane because the plane is using an event listener to do the animation. We don't need to animate it anymore, so we can remove the event listener. Again, so really proper cleanup here. We're removing all these extra functions. We're freeing up some memory so we can add more planes. Now, I'll be honest with you, this is the most very basic way of adding enemy planes, and I would recommend when we move into more complex programming that we're going to have a plane manager, or like almost like aliens. Like we're going to have an alien or some kind of enemies. We're going to have a manager that keeps track of all this stuff and adds planes into an array of planes that we're going to basically pop off the stack of the array and then display the plane itself. And then eventually what we're going to add that plane back into memory. Why would I do that? Why would I load up all my planes at first and then put the planes back into memory afterwards? Like almost like instead of having planes load here at runtime, why would I just load them in all at once? Why is that better? Just from a thought process perspective. Wasn't it better for me to preload my graphics? From a performance perspective, it is better. Every time I instantiate an object, there's quite a bit of overhead, right? From a game building perspective. Every time I instantiate an object, boom, it costs me overhead. It costs me cycles, machine cycles for me to do that, right? So it's better if I've already instantiated all my objects, right? They're inside this plane array, if you will. That's a better way of doing it. And we're not going to hit it this time. We're probably going to hit it next week when we get back after the break, right? When we create this manager that manages our planes, we load them up, and then we show the plane, and when we remove the plane, we remove it from the screen, but we put it back into the array. We kind of say, okay, I've got my plane now. I'm throwing it back into my pool, a pool of sprites or movie clips, as opposed to I'm going to load things. I'm going to instantiate the planes at runtime. That's bad, right? Unless you have a limited amount of planes, and then you're going to just instantiate a few of them. But if I'm instantiating like 100 planes or 1,000 planes, it's better for me to do it right away. I have all that memory, and then I'm going to just reuse that memory pool over and over again. It's a lot better from a runtime perspective. Okay, so now we're going to go to the RemovePlane event. Well, here we're going to go to, the only way we're going to remove the plane, there's two ways. We're going to remove the plane when it leaves the screen. That's one way. And we're also going to remove the plane when it's hit, right? So when the plane is hit, that's when we're going to remove the plane. So there's two options to remove the plane. So a plane's been hit by a missile, like a bullet, or if the plane is removed because it's off the screen. If the plane is hit, right, we're still going to remove the event listener for the frame. We want this plane to stop animating, so we're going to clean that part up, right? Then we're also going to remove the plane from this, and we're also going to go to and play the explode part of the movie clip. See where it says go to and play? We're not going to do a go to and stop in this particular case. Remember, the plane is a movie clip, and it has 3 frames of an explosion, right? 1, 2, 3. And then when the plane gets to the last part of the movie clip, let me go back to the plane itself. I have this last movie clip here, and inside this last movie clip, right, I have a stop button, right? So here's in my play, I have this start air raid, right? In my intro, I have this stop button, right? And I have this embedded in frame 1. And in my game over state, I have in frame 3 of my game over, there's 1, 2, 3 frames, right? I have different things embedded here as well. So why is this bad? I mean, here's another thing that I don't like. I have a bunch of little code embedded inside my movie clip, inside my main timeline. So I got to keep track of that code too, because this stuff is going to take place as well, right? Because I have a mouse event, a click mouse event in frame 1 that I'm waiting for you to play the game, so start playing the game by clicking that button. I also have in frame 2, which is where our game is, I'm going to start the game. I'm going to go start air raid, right? And then in frame 3, I'm going to have this, this play. I'm going to go play again. But I also have in here, inside the plane itself, if I double click on the plane, now inside the plane, and if I look at this this keyframe itself, right? If I go to the actions of this keyframe, I have parent, remove child this, and I have a stop action inside my keyframe for my plane. And the reason for that is because the plane has exploded, and I want to remove the child from the screen because my plane has exploded. So I have that as part of this. I don't have to do that. I don't have to have the plane work this way, right? I'm doing it because this is the easiest way for me to create an animation. So I play my explosion animation, and then I stop the animation. But theoretically, what I could have is an explosion graphic, which is a better way of doing things. I'd rather have an explosion object as opposed to have my plane have the explosion with it. Then I don't need this go to and stop or go to and play plus this other timeline animation that I can remove, because if I don't know this is there, it's going to screw me up when I'm programming. And it's happened before. You're programming, you put a couple things in the timeline and you don't know where it is, and all of a sudden, oh yeah, I got the stop action that's in my in this frame of my plane. It's too unorganized for most programmers, and that's why they don't use Flash. They use something like a Flash Builder or Flash Developer, FDT, and everything is inside those. All the pieces of their classes are inside there. It's not on the timeline at all. Okay, let's go back. We're almost done this one, and we're going to take a bit of a break to get some coffee. Okay, so we remove the plane, and we're going to do that when the plane has been hit. So there's 2 parts to remove the plane. One part is when the plane's been hit, one part when it's off the screen. Okay. Here's when we have the airplane itself, right? Here's when we test the class. I have a new airplane, and this is where I'm telling you that in more advanced parts of this type of code, we would probably have some kind of pool, an airplane pool, as opposed to just like creating an airplane like this. We're instantiating it here, right, at runtime. We're instantiating one plane. And its direction to test it is right. It's right direction. And our speed is 170 pixels. That's the second option. And then the altitude is 30 pixels. That's our plane, right? So it's going from the left, from the right, traveling to the left, and it's going 170 pixels per frame, and it's going 30 at an altitude of 30. Okay. Let's take a look at that class a little more closely before I move on. So here's our airplane class. And if you notice, there's a bunch of stuff in here that we didn't talk about yet. I want to talk about it with you. So here I have a dx, which is our speed and direction, like I said. And if you notice, this is the exact stuff we talked about in terms of what we're receiving the airplane when we create our airplane. This class we've kind of gone through already, right? We've got our move plane class. We've got our plane hit. This is what happens when we delete plane. We haven't really talked about this function here. When we delete the plane, right, we remove it again, the enter frame event when we delete the plane, right? And we also remove the class itself, right? So we remove it. But notice, look, it says remove plane this, right? Remove plane this. So all we've seen so far is, if you notice, because we're looking at this parent class, our parent class, we're using the remove plane method. So that means our method for remove plane doesn't exist here, right? Because we're calling the parent method, our parent method remove plane, which exists where? In our air raid class, right? So here our air raid class right here, airraid.as, this is where we remove our plane, right? So if we look down to see where that happens, okay, here's our new plane, right? Check for hits, key down functions to move our plane around, fire bullets, show the game score. Oh, here's our remove plane function that's inside of our air raid action script file, right? And what we're doing is we're saying remove that plane from, what we're going to do is we're going to pop the plane, splice it from the plane array, okay? So splice it or move it from the plane array. We're going to talk about this in a bit. Okay, let's go back. Now we're going to go to moving the gun. Okay, so again, the gun moves only left and right. That's the only way it can move, right? And we have an AA gun, anti-aircraft gun class that we're going to use to move this thing left and right. So what does this anti-aircraft gun class do? Well, it takes, it doesn't take anything in its constructor. So we're not listening for parameters in the anti-aircraft gun. So what can you give it, right? But it does have a few instance variables. One of them is this last times, because you're going to animate the gun is going to animate, right? We also have a constant, all right? And remember, when we define a constant, our syntax for a constant is static const. If you notice, there is no var keyword when we create a constant because that would make it a variable. So it's either static variable, that doesn't make sense, or static constant. Static constant is the one that you want to use. All right? Static constant, it's called speed, and it's a number value, a number data type. In this particular case, it's 150.0 pixels per frame is what we're going to be traveling at for our gun, right? Okay, the other thing that the gun has, the anti-aircraft gun, is an X and Y position that's fixed. So our X and Y position is at 275 and 340. That's where it starts off, right? And then we're going to add an event listener for another enter frame event. So remember, we have an enter frame event for our plane. Then we use another enter frame event for our gun, right? Because remember, these enter frame events means every frame check for something to happen. That's what we're doing here, right? Alternatively, and this is where I think the better way to do it is, we would have an update function like we did back in the day with Python. Every one of these objects should have their own update function, and we should be updating the functions every frame. And the frames, this enter frame event should be called once, because it takes a lot of more cycles to have multiple enter frame events, right? Once from the main game class that we're going to be running. That's the better way to do it, almost like this game loop that we're going to be running, right? Here we're not doing that. Each of the objects have their own enter frame event. Okay, that's one part of the gun. The other part is the move gun. So in every enter frame event, we're going to check to see if the players press the buttons to move the gun, right? That's what we're going to do here. Okay. So when we move the gun, it's going to basically say, depending on if I've clicked the left arrow or the right arrow, depending on which arrow I've clicked. And I'm going to go to my parent class. I'm going to go up one to my parent class, which is airraid ActionScript, airraid.as, right? We're going to go to that one. And we're going to use the left arrow method. We're going to fire the left arrow method to say if our left arrow has been chosen, if left arrow is true, we're going to say our new x position is a negative equal to the speed, because we're going to go left. And anytime we go left, it's a negative value that we're traveling, times the time elapsed. Okay? If we're moving to the right, then we're going to say our new x position is plus equal, not minus equal, the time elapsed times the speed, right? And then we're going to check our boundaries. We're going to do some boundary checking, because our gun can't go off the screen, right? It's got to stay on the screen, right? So we're going to say if our x is less than 10, right, then we're not going to let it go less than 10 pixels to the left. So it's going to stay on our screen. We want the whole gun to stay on the screen, so we're not going to let it go less than 10 pixels from a positional perspective. And the same thing on the right. The gun, we don't want it to go more than 540 pixels, so it can't leave the screen on the right either. So we did a little bit of boundary checking there. And then we're going to assign our local x parameter to the new x position. Okay, that's what this thing does. It's interesting though, if we go back to our flash file, what we're doing is we're checking left arrow and right arrow, right? Left arrow and right arrow are Boolean variables. That's all they are. So we're saying go back out to the upper class, to our calling class, so our parent class, where I'm instantiated. Go up there and check. I want to use my parent class's left arrow and right arrow. I want to check to see if they're true. And if they're true, that's going to determine which direction I'm going to go in. Okay. There's many ways to skin a cat, so to speak, right? So there's many ways we could have done this. This is just one methodology that this particular book is using for that. Okay. So we've moved our gun. We have this key down and key up kind of idea. We're listening for this key down and key up coordinate. We're going to do that in the action script, the AS file, the air raid AS file. And we're listening for two key code events. Remember this key code 37 and 39, just like we did before. If we use only the key down event, we won't have this hardware interrupt movement where it's continuous movement, right? We need to use both the key down effect, key down event, as well as the key up method, right? We have to listen for both events to happen in order for us to know to constantly poll the keyboards. We have this hardware polling going on, so we have smooth movement when we use our arrow keys. Okay. So here we are. Again, we talked about doing some garbage collection before, and we do it for the gun as well, right? So we have this remove child event, and we also remove the event listener when we move the gun, when we delete the gun. And the reason why we do this is when the game is over, we don't really want our objects to be on the screen anymore, right? We want to remove them from the screen because remember, even though we're going to the next frame, we want to clean up our memory, right? Because if we play again, right, we might have this stuff that's hanging around, all these memory locations that have been allocated, and we're going to have less memory every time we restart our game. So we don't want that to happen. So even when our game is over, we've got to remove all the objects from the screen and free up that memory. All right, got bullets, right? We did our gun. We're almost done. We got our plane. I'm getting tired too. And we got our bullets. And if you notice, there are a grouping of bullets here, right? So we got a couple things we're going to talk about. We're going to talk about a hit test. So a collision test we're going to do in a second, right? And again, in a more complicated game, we're probably going to have some kind of collision manager where we can collide any object, any other object. And we're going to have almost like a collision class of its own. In this particular case, a simple game, the bullets themselves are going to handle some of the collisions, right? So let's talk about the bullet class. The constructor of the bullet, right? It takes, because it's moving, it's not like the gun that's fixed. It takes a bunch of parameters, well, three, an x and a y coordinate and a speed, right? So in other words, our beginning x and y coordinate, that's what it's going to take. It's going to take that point, and then it's going to go up a speed, and it's obviously going to go up the screen. Bullets aren't going to rain down on our gun. Our gun can't lose. Right now in our simple air raid game, There isn't any kind of bombs that are coming from the plane to kill us. We only have a limited number of bullets. That's what ends the game too, right? So our bullets move straight up. And our speed is going to be the speed that's passed in here into our gun. Okay. And we're going to have this enter frame event. So if you notice, look, each of these objects use this animated object model that we talked about in our first video for today, right? It goes to this move bullet. So it's the same template that we're using. We've created a template for our objects, and then we're moving our objects almost exactly the same. So to me, just a commentary for this kind of class, we could simply have made an animated object class, and each of these, which would be a movie clip, and each of these objects that we're creating would be a subclass of this animated object class. Now, to me, it sounds great, but some people would have problems with that. We wouldn't make it a subclass of movie clip. It'd be a subclass of animated object, which is also a movie clip. But at least it would have a set number of things that it'd be listened to, like X and Y coordinates, speed and direction, and so on. Okay, so let's take a look at the move bullet. Move bullet looks exactly like what we expect it to look like. We listen for the time change, and then what we do is we change the Y direction. Right? We add in the Y direction according to the time passed. And the delta Y is going to be a negative because it's going to go up. And going up from the screen, because remember the screen, the coordinates top left is 0, 0. And as we go towards the bottom right, we go positive. And as we go towards the top left, we go negative. So we have to actually have a negative number for the Y coordinate as the bullet flies up towards the screen. And then we're going to delete the bullet. We're going to do some of our own little garbage collection here like we talked about before. Okay, so we talked bullets. The last thing we need to talk about is this, the key down function. We're going to have to kind of modify it because we can move left and right, but we also want to be able to press the space bar, that's what 32 is, and to fire the bullet. So that's where we would fire the bullet, right? And that happens in our air raid class. Okay. So we fire the bullet. This is where we instantiate a new bullet. Why is this bad? Again, okay, so I'm instantiating a new bullet every time I fire it. Bang, 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 bang. I'm going to keep instantiating new bullets. It's great, but if I keep pressing the space bar, I'm going to run out of bullets pretty quick, aren't I? Right? It allows me to press the space bar as fast as I want in this particular version of the game. But what I do here is I'm going to push these bullets onto this bullets array, which is actually where we're going to keep our, I don't know, a pool of bullets that we're going to put into our, for our game. We're going to push this bullet B. After we've added child, we're going to add child, so we're going to display this bullet onto the screen in a particular location and update it every time we move it. It itself is going to update when the bullet itself is almost like self-sufficient. It's going to have its own X and Y coordinate and its own enter frame event operating totally on its own. There is no overall game loop. It's going to continue operating on its own until it leaves the screen or until it collides. Right? That's what these bullets do. But we also want to keep track of all these bullets. We only have so many bullets. Okay, here's our game class. So this is the air raid action script class itself. We have a bunch of things we have to do here for this one. So we have our objects we defined. Here's where the main stuff happens, right? We have to define our anti-aircraft gun. We have to have airplanes, an array of airplanes. Again, I would have, this is a pooled, an amount of airplanes I'm going to create. Instead of creating them on the go, I'm going to create them all at once. Same thing with bullets. Okay. I'm also going to have my left arrow and right arrow, because depending on what I press, I'm going to pass that information on to my my gun class, all right, when I move around. Okay, and a timer, of course. I'm going to have to create this timer so we can know when the next plane is going to come out. Because I want to use a timer, so the timer is going to be a random time for the next plane to come out. Okay? I'm also going to keep track of how many shots I have left and how many shots I've hit, how many times I've hit a plane. Okay, so I'm going to do some scorekeeping as well. All right, so I have this start air raid function, right? This is it's not our main function. It's not in the constructor, because we don't have a constructor function for this game, right? It's not starting on the first frame, right? So we don't have a constructor. We have to have this thing called start air rate, and that's what we call our start air rate function is called from our timeline. Remember? Let's take a look. Here's our timeline, right? And when I'm here, if I go to my actions panel into the intro, right, it takes me to my play state, my play frame, and then I call this start air rate function. So actually I don't call a constructor for my action script file at all. I call the start air rate function. If I look at air rate, here we are, right? Here's my start air rate function, right? Again, I personally think it's not cool that we do this, right? But I understand why we're doing it, right? We're doing it because we can't have a constructor. It doesn't start on frame 1. We have to call the constructor inside of our actions frame so we can encapsulate the game in these 3 frames using this method that we've been using. Okay, so that's the first thing we're doing. Then we're going to create a bunch of event listeners, right? 2 of them for keyboard movements, key up and key down, right? And so we're listening for any kind of keys being touched, right? And then another one for checking for hits. On an enter frame, we have our enter frame event, which is our main game loop, if you will. That could have been. We're checking for hits. And then we're going to set the next plane. All right, so start planes flying. Okay. Here's our set next plane function. Okay, we have a new timer, and it's going to be a 1,000 milliseconds, so 1 second, plus anywhere between 0 and 1,000 milliseconds. So anywhere between 1 and 2 seconds, minimum of 2 seconds before the next plane is sent. Okay? And then on the next plane, when we get our next plane, anywhere between, again, minimum of 1 second between planes. 1 to 2 seconds, okay, we're going to wait, and then we're going to add our new plane into the screen. Okay? We're going to start off with this new plane function. Okay? That's what we're going to do. We're going to start this ticker going. Here's our new plane function. Okay, what are we doing here with our new plane? Well, if math.random is greater than 0.5, we're going to flip a coin, and depending on which side we're going, we're going to fly either to the left or the right, like we saw before. Okay, so that's one thing we're going to do. Our side, we're going to decide right here. Same thing with our altitude. We're going to have a random altitude for our plane, anywhere between 50 and 70 pixels. Minimum of 20, maximum of 70 pixels we're going to add. That's the height of our altitude. Okay? And then our speed is anywhere between a minimum of 150 plus another 150 to 300 pixels per frame. That's our speed for the plane. And then what we're going to do is we're going to instantiate, we're going to create the plane, we're going to instantiate a new plane, right, on the go. This is what we're going to do here, right? And we're going to give it its the side that it's moving in, the speed that it's going, and its altitude, and we're going to add it to the screen. And then we're going to take this plane, P, this new plane we defined, and push it onto our airplane stack, our airplanes array. We're going to push it onto the array. Now we're going to see why we need this airplane array in a second. Right now, there's no reason for it. Why do we need an airplane array? No reason. Just keeping track of how many airplanes. And then we're going to go back and set the next plane. Back here. So if you notice, it's an endless loop, right? It's going to keep on sending planes forever. Forever and ever and ever and ever. Okay, that's one thing. We're also going to do this check for hits function. And the check for hits function, if you look at the way it goes, when we start air raid, we check for hits before we set up the next plane. And in fact, every frame we're checking for hits. That's what we're doing, right? So here we are checking for hits, and we're saying this. If the number of bullets, bullet number, right, is equal to bullets.length minus 1, right? So it equals to bullets.length minus 1. So bullets.length is an example. Every time I fire a bullet, it's 1, right? So I keep on adding them, right? If my bullet number is greater than or equal to 0, right? If I have more bullets than 0, right? Then I'm going to bullet number minus minus. I'm going to keep doing that until there's no bullets left. So I'm going to run this for loop until there's no more bullets. That's one thing I'm going to do. Okay? Now, within that for loop, I'm going to say for every airplane, depending on the airplane number, this is why we keep track of the airplane, because my airplane array keeps track of different objects on the screen. So depending on which bullet hits which airplane, it's going to remove that airplane from the stack, the airplane that gets hit. Okay, this is a funky, convoluted way of removing objects. I mean, it's neat and everything else, but probably better would be to create a collision manager where you actually have, okay, I'm checking the plane and I'm checking the bullet. I'm checking the plane and I'm checking the another plane. I'm checking a bomb and I'm checking the base. You know, it can check different things. In this particular case, I've got a nested for loop that's basically checking first if we have enough bullets, and then if we have enough bullets, we're checking to see if the plane and the bullet hit. And we're doing this simple hit test object. We're saying, let's take the bullet, whatever the bullet number is, check with the plane, depending on what the airplane number is. Have they hit? If it's true, then we have a plane hit, right? And remember when we run that plane hit, what happens? We remove the plane from the screen, right? That's one thing we do. And then also we remove the bullet. So we do two things. We delete the bullet and we delete the plane. Okay, that's what we do. And also we do shots hit plus plus. We want to keep track of our score. And we want to show our game score. Show our game score. What that does is it updates the game score. Okay, and show our game score happens way down here, right? So it's kind of a simple game, right? Overall, what we're doing here is firing bullets, but each of the objects themselves keep track of where they are, and they also keep track of how many objects. The main game class keeps track of how many objects have been fired or on the screen and so on. Now we could have an unlimited amount of planes in this scenario because we don't really limit how many come out. We do have a limited number of shots, however, and that's why the game can end. We use our end game scenario when I fire my bullets. So here's my fire bullets, and if I have no more bullets left, as an example, if my bullets are out, then I go to my end game scenario, right? Because I have no more bullets left. So now I'm doing all my cleanup again. If you notice, I remove my event listener from my keyboard. I remove my event listener from my enter frame event. I do all that kind of stuff, and after I'm done doing all that, I stop my next plane. I stop my ticker for adding new planes to the screen, and I actually set it to null. And then I use my go to and stop command, this timeline control, to move to my game over frame. That's what I'm doing. I'm going to that game over frame to allow the player to say, do you want to play again or do you want to quit? Okay. So again, I've kind of fast forwarded through these slides, but I think it's a worthy, a worthy exercise. Again, do I think it's the best type of collision? Well, if you notice, the bullets are kind of in a square pattern, right? So you have a square, and you're kind of coming at the bullets from underneath. So it's not like you can't hit a square surface. The plane underneath is kind of a square, so you're not going to, it looks pretty good. The regular collision detection works okay. I think the better collision detection is we actually have a radius, and you compare my ship's radius compared to your bullet radius, and then as they come closer than the difference, we have a collision. That's the better way to do it compared to using this built-in hit test object method. Okay, so I've kind of gone through all this already. Again, I think cleaning up after the game is probably paramount. So the next movie we're going to talk about a little bit of moving with sine and cosine and arctangent when we move around our screen. Right now, so far, up until now, we've kind of fired our objects in a straight line. And we don't really move in a diagonal.